Hello and welcome to Josh Walker's presentation of a mixed-use tower concept for development in Chengdu, China. There are two key questions when dealing with residential construction in China that I felt like addressing with this project. The first was the issue of comparing supply with demand and meeting demand appropriately. Because in economics what we deal with is, in this situation particularly, you need to meet a demand of, say, 3,427 one-bedroom units, 2,874 two-bedroom units, and you get that in all different varieties demanded. Some people demand a balcony and are willing to pay more for that. Some people demand access to social space. And so what you deal with is a very complex demand market. And so along the demand curve of people willing to pay a certain price for a certain product, we can aggregate that and say there's a sweet spot of matching everybody's demand perfectly. And at that sweet spot, if a supplier is able to do so, you can achieve the most product, provide the most social benefit, and still make a ton of money. And so that's the sweet spot of supply and demand in the economy. The problem is, that's really hard to do with residential construction. And part of that has to do with what we see when we look at residential construction in China. You see the same floor plan extruded up who knows how many times, often upwards of a dozen, and you just get 12 exactly the same towers that provide the same option for all of the market and doesn't really address customization or meeting demand at all, except that what it does is it oversaturates the market, and then you have to charge less in order to fill every unit. So it's not a very efficient system. It's not a very architecturally desirable system. And so I set out to design a better one. And so we start with a welded variability truss, or a rigid box frame, welded in the corners and factory manufactured. And this becomes basically the chassis or the frame of an apartment. And so the standard approach would be to put a cap and glass around it, and we can see that this would be a 3-bedroom unit, fully enclosed, and the dimensions of which are, if I remember right, 8 by 12. Yes, 8 by 12 meters. But of course we're going to have options besides that. We're going to have a studio, a 1-bedroom, a 2-bedroom, and a 3-bedroom so that we can meet everybody's demand needs. And so rather than surrounding them all in glass, what we'll do is we'll model the tower, and then we'll put solid walls where we need solid, and we'll put glass where we need glass. That will look something like this. So if I take the cap off, we're going to look down into the unit, and we can see interior walls separating the spaces. Now the question when always dealing with modular units pre-manufactured is, how do you supply air conditioning, water, and electricity? Well, this first step would be to handle AC internally. Because every unit has access to the outside, we can put a split mini system in place and run the services underfloor. Similar approach for the water and electricity. We run those underfloor and bring them to the center core for supply. So we put the raised floor in place, and you don't have to see the systems, and your units are taken care of. Finally, we'll put some furnishings in. Get some pretty comfortable spaces in here. The 3 bedrooms do get 2 bathrooms, and the 2-bedroom gets a Jack and Jill arrangement. Alright, so now that we have our units, what we do is we arrange them into floor plans. And in this case we have all the units centered around a 12-meter steel core in various configurations. And then we have 2 non-residential options. We have what I call a smoking or social deck, where just the core is enclosed and the exterior becomes a public patio. Or we have an office or commercial floor where it's all enclosed and you can use this as a small business space or a CVS or something of that nature, maybe a laundromat, to serve the needs of the tower and grant this a true mixed-use status. So, all in told, we have 24 residential floor plan options and 2 non-residential options, giving us 26 floors that then go into the composition of any tower, matching supply with demand. Now, in order to demonstrate that, what I needed to be able to do was produce an infinite number of towers with an infinite number of configurations, not something I was interested in modeling by hand. So what I did was I created a Grasshopper script that would create an infinite number of variations for me. And so, taking those floor plans and arranging them randomly, I fixed floors 1 and 2 as a base and a social level, and then the very top floor as a social level. And everything in between has a 1 in 26 chance of being one of the 26 floor plans. And so we look at two sliders, one that determines your number of floors, one which determines which iteration of tower you want, and then 3 toggles to actually produce the towers. And so if I bring this over here, we'll watch this in action with the base file, or with this base object being our starting geometry. And so I'll just go ahead and generate the majority of the tower here. And what we see is I can turn on the baked layers, and we'll turn off the trusses, the glass, and, I use truss and unit, because the units are individual truss, welded box trusses. And so we see that this has generated our circulation core with 2 sets of 2 elevators on either side of a scissor stair in the interior. And then we have your metal steel frame on the interior, structural steel, with the concrete floors for the core. And then all of the units hang off of that steel core. Now you don't see any lateral bracing, and that's what the next 2 toggles are for. So I bring this in here and I toggle generate points. This one takes a little bit to work because it contours the floors and creates points according to proximity to the interior generally. There's a little bit of geometry finagling I had to do to get this to work, but it works fairly well. And then last option is to generate a lattice. What the lattice does is it creates lateral bracing between the floors by connecting points up by proximity. And what I'll normally go in is I'll add some points in order to get it more artistic and more structurally viable. But this works as a fairly decent starting point. By the way, whenever I do go in and add points, what I'll do is just delete the stuff that bakes in the generate lattice option. So let's see, bake lattice, select objects, delete. Then I'll come in here, for example, select that point, and 8. -16. So for example, I'll do that, and then I just toggle the generate lattice again, and you can see how that's created a little bit more structurally realistic kind of lattice for resisting moment connection, or resisting moment torque in the tower. And so that's how you create your lateral bracing for a tower like this. Now every floor plan, or every iteration of tower has random floor plans. You can see this one doesn't have any office buildings, any office level type floors. And so each one's going to create a unique lattice and a little bit different aesthetic. So then I'll copy this. It'll take a while, but once it does, you can see how changing the sliders, including that number of floor slider, can give you all different iterations of tower with variable height, and completely random types of units. And so with this proof of concept for infinite variability, you have this option for infinite customizability and absolute matching of supply with demand, especially when you talk about a multi-tower site like our site is going to be. And so that's where we take advantage of the benefits of Unity and the full site modeling and the real-time rendering, and we can look at what these towers look like when grouped. And I've received surprising compliments from several reviewers who say that the towers group well. And that's probably because when you're accustomed to looking at multiple towers on a site, they all look exactly the same, and in fact these very much do not. So I'm going to try and take advantage of the jump feature in Unity and get us all the way over there to the other tower. Or do I really need to? Let's see. So where we are is we're on the top of one tower, and so if I go down into the central core, don't want to go down the stair or the elevator core, but I do want to come down the stairs. And I can walk us into, yes, alright. So this is an opportunity to look into the types of views and the experience that you might have in one of these units, this being a 3-bedroom unit. So what I want to do is I want to get us over to the other tower. That's the one I want. Sprint and jump. Hey, touchdown, I made it. Okay, so here we're on top of one of the towers, and I'm going to take the opportunity to just take us inside for a second and look at what these towers look like. Let's see if I can find the right. Okay. There we are. There's what I'm looking for. And I missed it. Oh well. But you can see the spontaneous balconies generated and the sort of options that you get for a developer could look at this and say, alright, I'm going to upcharge people for the balconies and strategically place the balconies by overlapping units for my higher paying customers, or you can just have it be random and be a value added benefit and let people fill out the balconies the way they want. Here we're on a social level, social deck. I think I need to go one more level up. Perhaps one more. Yes. And so occasionally we'll have these smaller patios built into the tower just as options for people who might want to have fewer neighbors and more access to the outdoors. They can have a social level, a social patio. And so that's my project for mixed-use tower development and site development for our site in Chengdu, China. Thank you for sticking with me through this 14-minute video, and I hope that this and the other projects that you'll see from my peers inspire you to do some incredible work of your own. Thanks.